Good morning. This is Miss Billerbeck, and we're going to do 14.1, solving quadratic equations by factorization. So let's remember that for any two real numbers, p and q, if p and q equals 0, then p equals 0 and or q equals 0. Therefore, these three little dots mean therefore, by the way. So let me point that out, because if you use that, then you look really sophisticated, and that's what I want you to look like. So these three dots mean therefore, for 9p squared minus 4 equals 0, which this factor, since it's a difference of squares, as 3p minus 2 times the quantity 3p plus 2. So what we can do is set this one equal to 0 and this one equal to 0. So when we do additive inverses and multiplicative inverses, we find that right here we have p equals plus 2/3 and p equals minus 2/3. Therefore, our solution set is plus or minus 2/3. So this is the way that we show plus 2/3 and minus 2/3 very succinctly or easily. So let's do some examples. So our first example, 5x squared minus 8x minus 15. So they don't have a common factor. So now let's do the diamond box. So we have 5 times negative 21, which happens to be negative 105. And we have negative 8 down here. So we know that the two factors are very close together. And we also know that the bigger one's negative because this is negative. So let's quickly look at what factors we might have. So it multiplies to be negative 105, and it adds to be negative 8. Okay, so while we know 5 and negative 21 are factors, and when we add that together, we get, let's see, that's negative 16. There we go. It's not quite 8, so we need to get them closer together. So these factors are 3 and 7. So if we take the 3 out of this 21 and multiply it by 5, that's 15, and make that negative 15, and that leaves us 7. When we add that together, we get negative 8. So see how quickly we can find it once we get it to smaller numbers, and we know there's only two factors of 21. So what we have to multiply 105 is 357. So then that makes it really easy to find what these are. So we have negative 15 and we have positive 7. So let's do our box. Okay, so first term goes in here, 5x squared. Last term, negative 21 right here. Then we do one diagonal, negative 15x. The second one is 7x. So our greatest common factor is 7. Here it's 5x. Here we just have an x. And then here we have a negative 3. So this factors as 5x plus 7 and x minus 3. Let's double check that. 5x squared, negative 15 plus 7 is negative 8x. And then 7 times negative 3 is negative 21. So let's set 5x plus 7 to 0 using an additive inverse of negative 7. We get 5x equals negative 7. Using a multiplicative inverse of 5, divide by 5, and we get x equals -7/5, otherwise known as -1 and 2/5, because there's 1, 5, and 7 with 2 left over, so 2/5. Okay, here is pretty simple. X minus 3 equals 0. Use an additive inverse, and we get x equals 3. So our solution is -1 and 2/5 and 3. And that is that. So we have solved it. Okay, so now let's look at this one. So we have to do a little work. Okay, so we've been using the box a lot, but let's try the FOIL method. So FOIL involves first, outer, inner, and last. Okay, so that's FOIL. So 9x times x is 9x squared. Then 9x times -2 is -18x. -1 times x is -1x. And -1 times -2 is +2. And then we have -7x minus 2 on the other side. All right, so we want to start combining things. Let's first add this 2 over here. And then we'll simplify this right now. So we have 9x squared. That's minus 19x plus 4 equals -7x. And now let's use another additive inverse of plus 7x plus 7x and get that. So we have 0 on one side. So we have 9x squared minus, this becomes 12x, -12x plus 4 equals 0. Okay, well, let's do a little diamond box. Okay, so when we do a diamond and a box, we have 9 times 4, which is 36, and -12 right here. So we look at, well, what becomes 36 with multiplication, and this looks like it's going to be 2 negatives because that's a positive and this is a negative. So we have to think about what adds to be 12 and multiplies to be 36, but they're both going to be negative. So let's look at a few factors of 36. And then we have -12. Okay, so we have -4 and -9. That's positive 36, but it adds to be -13. We were so close. Okay, how about -3 and -12? Well, that's getting a little farther away. -15. Probably -6 and -6. There we go. There's our -12. Okay, so I bet a bunch of you saw that and they're like, and you were probably saying, Miss Billerbeck, seriously, you didn't see that? Oh. And no, sometimes we just don't see it. So that's why we had to have these other tools to find it. Okay, so we put 9x squared right here and 4 here, and we have, and this 4 was made by a negative, so we have to note that there was a negative. Okay, so we have -6x and -6x here. So that gives us a greatest common factor here of -2. And then this greatest common factor is 3x. This is also 3x, and this is also -2. So what this ended up factoring, not that one. Okay, so that did not factor to this because that's not at 0 yet. So what we're dealing with is 3x minus 2 times 3x minus 2, otherwise known as 3x minus 2 squared equaling 0. So that makes it super easy. We just have to set one thing to 0. So 3x minus 2 equals 0. Use an additive inverse. And we have 3x equals 2. Use a multiplicative inverse to get x by itself. And we get x equals 2/3. That is our solution, 2/3. Use a little tilde to do that, or we can say if we only have one, we can just say x is 2/3. Okay, so that would be the solution for this problem. All right, let's look at our last example. This is a practice in distribution and using inverses. So we distribute this 2x to both of these and this 9 to both of these. So 2x times 5x is 10x squared. 2x plus 3, 2x times 3 is plus 6x. That side equals 9 times 5x, which is 45x. Well, maybe I'll even put the 5 there. 45x, and 9 times 3 is plus 27. So now we move everything over here. So negative 45x is our additive inverse there. So we have 10x squared. When we subtract that, we get negative 39. X equals 27. Now we're going to move this 27 to the other side. And we get 10x squared minus 39x minus 27 equals 0. Once we've got it equaling 0, we can use the diamond box. Okay, so if we look at this, this is not divisible by 3 or 13, and this is 3 times 13 is 39. So we don't have a common factor to remove. So now let's do the diamond box. So we're going to have some big numbers here. We're multiplying 10 times negative 27 is negative 270 and negative 39. So these numbers are pretty far apart. And one's negative, one's positive. So let's do the brutal way of doing this. Negative 270, it multiplies to be that, and it adds to be negative 39. All right, so first of all, we know that we have 10, let's see, 3 times 39 is one of them. Let's see, we want it to add to 39, so it has to multiply. So we know that we have 10 and negative 27, but that's, when we add that together, it's negative 17. So we need to be farther apart. So let's try 5 times negative, doubling that, I get 54. Well, that gives me negative 49 when I add that together. So they need to be a little closer together than that. So let's see. I have 5. What do I have in between? I have 9. So let's try 9. And that gives me 9 and negative 30. Okay, so that gives me negative 21. Okay, so that's, I'm not getting very close. I need to be between 5 and 9 now. Okay, so if we look at the factors that we're dealing with 6. Let's try 6. Okay, so if we divide this by 6, we get, there are negative 4, 24, 30, 45, and there we go. That one took a little bit, eh? So that's 6 and negative 45. Okay, so we finally found it. So let's do the box. We can do the box here. We don't have to be way over to the side. Okay, so the first term 10x squared is here. The last term negative 27 is here. We have 6x. We have negative 45x. So our greatest common factor will be 9, negative 9, and this one will be 2x. This one we have 5x, and here we have 3. Okay, so this is going to factor as 2x minus 9 times 5x plus 3. Okay, let's double check that. So 2x times 5x is 10x squared. 2x times 3 is 6x, and this is negative 45x. Which added together is negative 39x. And then negative 9 times 3 is negative 27. Okay, so we did it. So this is 2x minus 9 equals 0. Use an additive inverse. And we get 2x equals 9. Use a multiplicative inverse. And we get x equals 9 halves. Now let's find the other solution. 5x plus 3 equals 0. Subtract 3 using an additive inverse. That becomes 5x equals negative 3. Now we'll use a multiplicative inverse. And we get x equals negative 3/5. So our solution set is negative 3/5, and 9 halves is 4 and 1/2. So we'll write 4 and 1/2. All right, that's it for section 14.1, solving quadratic equations by factorization. Have a wonderful day.